Getting ready for algebra, page 56. This particular section, we're going to do the next step in our algebraic adventure here. In the last section of algebra, we worked with problems that are in this form. X plus 3 equals 5, and x minus 3 is 5. Those type of deals, we're working with the minuses and the pluses. Here our goal is to solve an equation in the form of a times x equals b, and these would be whole numbers. And then a variable divided by whole number a is equal to whole number b. And then these are the examples of problems such as those. So in the opposite here, remember we did take away 3 from each side of a balanced equation. And here we added 3 to each side of a balanced equation. So we're going to do the same thing here, but our operation is multiplication. This means 3 times x equals 15. If a number is right next to a variable, it's going to mean multiplication. So this is 3 times x. So the opposite of times is divide. And we're going to always divide by the number in front of the variable. So we're going to divide each side by 3. Again, we're going to do it to both sides. If we do it to this side of the balanced equation, we have to do it to that side. Well, how many 3's in 3 when we divide? Well, 1. So we're left with 1x. We really don't need to write the 1 in front because we know that this is 1x up here. It's the same principle. So basically, we're just left with x. These cancel. And how many 3's in 15? 5. So then we plug it back in as a quick check. 3 times 5 is 15. We know we're good. In this form, this is a division. So we have z divided by 4 is equal to 5. Well, the opposite of divide by 4 is going to be to multiply each side of a balanced equation by 4 in this case. If it was divided by 5, we'd multiply by 5 and so on. But in this case, we're dividing by 4. So the opposite of dividing by 4 is to multiply by 4. So whole numbers go over 1. So how many 4's in 4? Well, that's 1. 1. That cancels out. We're left with 1 and 1. So we have 1 times z over 1, or z. So z over 1 is really just z. And 4 times 5 is 20. Again, a quick check. 20 divided by 4 is 5. So as we look to do our homework, I picked a couple of examples of the same things we just practiced on. Problem number 4 is 8x equals 32. So this again means 8 times x. So we're going to do the opposite of times, which is going to be to divide. And we always, always, always divide by the number in front of the variable. In this case, it is 8. If we do it to one side, we do it to the other. How many 8's in 8? 1, 1x, or just x. How many 8's in 32? 4. Quick check. 8 times 4 is 32. Everything's good. Problem number 7 is b divided by 2 equals 23. Numbers are just getting a little bigger to work with here. So the opposite of divide by 2 is to times by 2. And we do it to both sides. Say 2 and I write b. Okay, times by 2 to both sides. Okay? So, again, whole numbers go over 1. So how many 2's in 2? 1. So they basically just cancel. We're left with b. 2 times 23 is 46. Plug it back in real quick as a check. 46 divided by 2 is indeed 23. So all of these problems are exactly the same. So if I have x divided by 4 equals 9, the opposite of divide by 4 is going to be to multiply 4 by 4. Going to cancel, because how many 4's in 4? Okay, it's 1, so that cancels. And then 4 times 9 is 36. And if I had 3x equals 10, actually I don't want to do that. Let's make it 30. Okay? And if we're going to divide by the number in front of the variable, we're going to divide by 3. We're going to do that to both sides of the balance equation. How many 3's in 3? 1. So I'm left with the 1x, or just x. 3's in 30, 10. Do a quick check. 3 times 10 is 30. We're all set. Good luck with the homework.